Okay, guys, so what we've looked at the last couple of days is working with these models, and we've looked at how do I create a model and write the equation from that model. And then we've also looked at how do I solve given an equation like this over here with substitution, right? What number can I put in for x that makes it balanced on both sides? And so that is one way to solve it. Okay? The other way to solve is what we call inverse operations or inverse steps. And so we've looked at solving models with inverse steps a little bit already, and you haven't really realized you're doing it. And I know I mentioned it to a few classes, but we are really going to now really hone in and really start to sharpen your inverse operation skills. And so we're going to look at how would I solve it with the model, and then how does that correspond to what I would do in the equation. Okay? So when I have an equation, remember, I'm always solving for a one variable. I want that one variable. In this case, I want to know what this one x is worth. The same thing with this equation over here, right? We want to know what the value of x is to make this true. So let's look at what we would do with the model first. So if I'm trying to get down to 1x here on the left, I need to get rid of these positive 4. To do that, what we're going to do is we're going to make 0 pairs, right? We can't just get rid of something in math. We've got to do something mathematical to do that. So to do that, I need to make a 0 pair. In order to make a 0 pair, I need to take a negative and pair it with a positive. So for every positive, I'm going to add a negative. So what I've done over here is now canceled them out. Positive, negative cancels out. Positive and negative cancels out, and so forth until they're all gone. But now this is unbalanced, right? We talked about we've removed something or we've added something and it makes it heavier on one side. So the reason why we call it an equation is because we want to keep it equal, or we want to have equality, right? So if I added 4 negatives on one side, I'm going to have to add 4 negatives on the other. To make 0 pairs and to cancel out. So if I put a negative here, well, I know that can cancel that out. I know that can cancel that one out. And remember, I want to match these 4 negatives. Okay, so the reality is here is that what we've done is really we've added 4 negatives, but when you add 4 negatives, the reality is what you've done is just subtracted 4 from both sides. So when we look at solving inverse operations, one of the first things that you want to do is take a line and draw it straight down from the equal sign. It's going to help you keep equality. It's going to help you see balance. It's going to help you figure out what it is that we're doing. Because what we do on one side, we need to make sure that we do on the other. Make this line a little thicker. Okay. So step 1 over here in the model was to get rid of the positives by adding 4 negatives. We're going to do the exact same thing over here, except this time instead of looking at it pictorially, I'm going to look at it algebraically. So adding 4 negatives, like I said, is the same as subtracting 4. Make this bigger. But whatever I do to one side, I have to do to the other. Now, what I have to pay attention to is what did I take 4 from? Did I take it from the x's or did I take it from the positives? And I can't take 4 from x because x's are x's. And what we do is we take numbers from numbers. So we call this like looking at like. So I'm going to work x's with x's and numbers with numbers. So I'm going to say, well, I can't take 4 from an x, but I can take 4 from a 6. So when I do that, this equation now becomes, move it down, a little different. So no longer is this plus 4 here. It's gone. Eliminated it. Now we're going to say, well, 6 minus 4, well, what's left? Well, if I look over here on my equation over here, I have 2 positives, and we know that 6 minus 4 is equal to 2. We undid it, right? So we had a positive, We undid it. So we subtracted to get rid of it. We wanted to eliminate it, so we did the opposite of what was being done. So if I'm adding 4, then I want to subtract 4. But in order to remain balanced, whatever I do on one side, I have to do on the other. Okay. So now I've got this guy x right here by himself on the equal sign. I want to get rid of him. So we need to do an inverse operation. I can't just remove him. I need to take him away. So to do that, we need to make a 0 pair. So just like we had a positive 1, I paired it with a negative 1. I can pair a positive x with a negative x to cancel it out. So when I do this, they cancel each other out. So like these guys canceled each other out. That's a 0 pair. That's a 0 pair. 0 pair. He's gone as well. And he's gone. He's gone. Same thing here, right? We got 0 pairs. We can eliminate all of this because they're 0 pairs and they're gone. All right, so these are all. So I'm left with 3x. So let me recap because I did a lot there. We were left with 3x is equal to 1x plus 2. Remember, I want the x's by itself, so I want to get them all on the same side of the equal sign. So to do that, I need to pair it with a negative x to make a 0 pair. So when I do that, remember, whatever I do on one side, I have to do on the other. So a negative x and a positive x add up to 0, and they cancel out. So I'm going to look over here. Is there anything I can cancel on this side? And I do see something I can cancel. So that leaves me with 2x is equals 2. So let's go look at what we did algebraically over here. I added a negative x, which we are going to say is the same thing as subtracting an x from over here. Whatever I do to one side, I have to do to the other. So 3x minus x is going to give me 2x, and x minus x is going to cancel out. So what do I have left is this is gone. So I have 2 positives and 2 x's. The last step is to just figure out, okay, well, I want to distribute these evenly. So I want to divide, right? That's what we talk about, distributing evenly. And when I divide, I know that this guy gets 1x, or this x gets 1 positive, this x gets 1 positive. So therefore, my answer is x is equal to positive 1. So if we come over here and we look at what we did algebraically, I took the coefficient, because we know this is actually being multiplied. We've talked about this. And I divided each side by the coefficient. Let me make sure you guys can see these lines. All right, so I took the coefficient here. I divided by the coefficient because I want to undo it, right? We know when there's 2 and an x, we know that's a multiplication going on there, right? 2 times some number gives me 2. If we go back to substitution, right? Well, 2 times what gives me 2, and we know that that's 1, which we do know. We find out that is the solution after we divide. What we did is we undid all these operations to get down to x is equal to 1. All right, so on the next, in the activity on Schoology, there's going to be another video for you guys to watch about inverse operations. So this is just an example we went over in class today. But if you have more questions, obviously shoot an email to your teacher and our Code One Tutoring, and we'll be more than likely to help you guys. But we are going to be spending the next couple of days doing a lot of inverse operations. So if you're not 100% comfortable in it yet, it's okay. Still try it, work through it, figure out what you can do to get better at it, or figure out what kind of questions you have to bring on Monday. All right, guys, hope you have a good weekend. Make sure you do your practice, and we'll see you guys Monday.